Here are 8 examples of what are called one-step equations. They're called one-step equations because we can solve them all in one step by performing one inverse operation to solve for the variable. For example, in x plus 2 equals 4, we're trying to solve for x. We want to figure out what plus 2 equals 4. Well, to solve for x, we need to get it by itself. Right now, it's not by itself because 2 is being added to it. We can undo that by performing one inverse operation. The inverse, or opposite, of adding is subtracting. So to undo this addition of 2, we just need to subtract 2. But remember, this needs to be done to both sides to keep the equation balanced. We subtract 2 on the left, and we subtract 2 on the right. On the left, subtracting 2 gets rid of the plus 2, and so we only have x, just as we desire. On the right, 4 minus 2 is 2, and that is the solution. X equals 2. We can of course plug that back into the equation and verify that it works. 2 plus 2 does indeed equal 4, so we've solved it correctly. Again, we performed one step to solve the equation. There was one thing being done to our variable, we did the inverse, and that solved for the variable. In the next example, we have that y divided by 4 equals 2. We must perform one inverse operation to get rid of this division by 4. Now the inverse, or opposite, of division is multiplication. So what we need to do is multiply by 4 on the left, and of course multiply by 4 on the right in order to keep the equation balanced. Instead of using the x's for multiplication, you may prefer to just use dots. That way we don't get it confused with the letter x. So we multiply by 4 on the left, multiply by 4 on the right. On the left side, multiplying by 4 will undo the division by 4 and just leave y as we desired. On the right, multiplying 2 by 4 gets us 8, and that's our solution. Y equals 8. Again, we could plug it in to verify. 8 divided by 4 does indeed equal 2. In the next example, we have g minus 3 equals 10. To solve for g, we must perform the inverse of subtracting 3. The inverse of subtracting 3 is to add 3, and we must do this to both sides of the equation. On the left, minus 3 and plus 3 cancel out, leaving behind just g, and on the right, 10 plus 3 is 13, and that is our solution. 13 minus 3 equals 10. In our next example, we have 3h equals 6. What is happening between the 3 and the h? Well, it's not explicitly written. You should understand this is multiplication. This is 3 times h. The opposite of multiplication is division. So we need to divide here. But what should we divide by? We don't want to divide both sides by h because we have h right here. We want to leave it alone and just get it by itself. So to get it by itself, we need to get rid of this 3 that's getting multiplied by h. Thus, what we actually have to do is divide the left side by 3 and divide the right side by 3. This is performing one inverse operation to solve for the variable. On the left, dividing by 3 will cancel out the multiplication by 3, and thus we'll just have h. On the right, 6 divided by 3 is 2, and that is our solution. 3 times 2 equals 6. We'll go through 4 more examples. Why don't you give them a try yourself before watching the rest of the video? Hopefully you've done that. Let's get into it, beginning with this next example, 10 equals 14 plus w. Which side of the equation the variable is on does not matter at all. If you prefer, you could rewrite this as 14 plus w equals 10 if you like to have the variable on the left, but it makes no difference at all, so I'm going to leave it alone. In this case, 14 is being added to w. We need to undo that, so subtract 14 on the right and subtract 14 on the left. Remember, we've got to keep the equation balanced. On the left, 10 minus 14 is negative 4, and on the right, the 14 and the minus 14 cancel out, leaving us just with w. So w equals negative 4. That is our solution. Next, 15 equals 5 times a. To undo this multiplication by 5, we must divide by 5. And of course, we have to do it on both sides. On the left, 15 divided by 5 is 3. And on the right, dividing by 5 will cancel out that multiplication by 5, just leaving a as desired, and that's the solution. 15 is equal to 5 times 3. Two more problems to go. Next, we have 12 equals x over 2. This is just another way of writing division. Here, x is being divided by 2 in the fraction. So to undo that, we must multiply both sides of the equation by 2. Again, using the dot for multiplication so that we don't get it confused with the letter x. On the left, 12 times 2 is 24. And on the right, multiplying by 2 will cancel out that division by 2, and thus we'll just have x as desired, and that's our solution. X equals 24. Again, to solve these one-step equations, you just need to perform the one inverse operation that will get the variable by itself. In our last example, 3 equals y plus 10. In this case, 10 is being added to y, and to undo that, we simply subtract 10 from both sides. On the left, 3 minus 10 equals negative 7. And on the right, subtracting 10 cancels out with the plus 10, and so we just have y on the right. And that's our solution. Negative 7 equals y. Again, remember, you can put the variable on the left if you prefer, so we could write y equals negative 7. It really makes no difference. And that is how you solve a one-step equation. Let me know in the comments if you have any questions, and check out my pre-algebra exercises and pre-algebra course playlists in the description for more. Thanks for watching. Couldn't even open myself up for an instant.